morning, everyone. How are you? Today's session here we'll speak about the thermal physics, and you have to understand that the thermal here means the energy of heat. We said here that every a theory that speaks about any type of matter, it's being related to thermal energy. We can say this according to the shape of each material alone. For the solids, as you can see, the particles are held together by very highly attractive forces. They are held together in their place and they can be vibrating within a limit area. And also we can find that all of the particles are arranged regularly and they have repeating pattern. And we can say that the thermal energy found inside them is not as huge as other materials. When you go to the liquid, you can find that they gained a little amount of the thermal energy, which makes them able to flow easily around each one. They are kept flying apart, and this happening by the attraction force that happen between each particles. And you can find also that the liquids here taking the shape of their containers. When you go to the gases, by increasing the amount of the thermal energy, you can find that there is no control over the movement of particles. They can travel in different directions with a very high speed, and the attraction force between them can be said that it's very neglected. This happening because of the increasing amount of the thermal energy found inside them. Plasma here, it have a very high temperature for the found inside the stars or atoms when they can lose their electrons. By losing these electrons, the picture here being found between electrons and nucleus, resulting for the shape of the plasma itself, which is a type of a state of matter, which means there is an increasing amount of energy, as you can see the arrow. For understanding the temperature here of any object, the temperature is here describing how hot or cold an object is, which is determined the direction of the heat that happens between two bodies. Thermal energy, they can transfer from an object with higher temperature to a lower temperature one. Thermal energy here, you can find that when the energy is transferred, means that you are speaking about the heat, and it is happening because of the thermal temperature difference happening between each object. The objects here, which are in a thermal equilibrium, they have the same temperature, and also the absolute zero is 0 Kelvin or minus 273 degrees on Celsius. Those are two thermometers degrees they are using, and also the third one will be Fahrenheit, and we will talk about this later. How could the thermal energy transfer by three ways: by conduction, convection, or radiation. Conduction here, when the energy transfer by direct contact. Convection happening when the mass motion happening of molecules. The hot objects will travel to the top, cold objects will move down, and both of them, they need a contacting, whether direction as the conduction or indirect by the convection. Radiation here, it happens when the electromagnetic radiation happening as waves. The heat is traveling as waves, and this happening through the sun as an example for it. You cannot find that there are two touching materials happening to move the transferring energy. If you want to compare the three types of the thermometer or the scales, there is a Kelvin, Celsius, and Fahrenheit. There is a freezing point down and boiling point on the top. Each one of them has its own degree. The 0 degree Celsius for a thermometer equals 273 for the Kelvin and the 32 Fahrenheit. And the boiling point for a pure water on the Celsius, it's 100 degree, and it's 373 Kelvin and also 212 Fahrenheit, which means there's a caliber between the three differences. We can say that the Kelvin minus 273 over 100 equals C over 100 equals Fahrenheit minus 23 over 180, and this happens when you compare all of the temperatures together. So if I want to compare or change from Fahrenheit to Kelvin or from Kelvin to Celsius, there are four major equations that makes us understand how they are equaling each other. We can say here at number one, if you want to change it from Kelvin to Celsius or from Celsius to Kelvin, that Celsius equals Kelvin minus 273 or Kelvin equals Celsius plus 273. The same here for Fahrenheit. If you want to change it from Fahrenheit to Celsius, Celsius here equals 5 over 9 multiplied by Fahrenheit minus 32. And also we can say that Fahrenheit equals 9 over 5 multiplied by C plus 32. If we have a check here, he said converted 20 degrees Celsius to Fahrenheit and Kelvin. From Celsius to Fahrenheit, which means equals 9 over 5 Celsius plus 32. You remove the Celsius and write 20, and then you can find at the end it equals 68 Fahrenheit. and from Celsius to Kelvin, which means Kelvin equals C, which is Celsius plus 273, which gives me 293 Kelvin at the end. Try to find your classwork being done here by these three converters and give me the answers and submit it back.